Okay, so let's talk about factoring quadratics. When we have a quadratic in the form ax squared plus bx plus c, we're going to do a couple of things. In all our examples for this video, a is going to equal 1. So there's a couple of steps that we're going to skip in the full process, but we'll get to those in the next video. Since a is going to be equal to 1 in this case, we're going to have something like we're going to have like x squared plus bx plus c. And we need to figure out what two numbers multiply to make c, but add together to make b. And that's the process that we're going to follow for each of the quadratics. Once we know that, we can use the two numbers. We're going to call those our key numbers. We can use our key numbers to write out the factors of this quadratic. And like I said, since a is equal to 1 in all of our quadratics for this video, we're going to take some shortcuts. Usually you'll need to turn the x term into two different terms and then factor out by grouping. But when a is equal to 1, you get to skip that and just use the key numbers that we find from over here to just write out your factors directly. So let's jump in and take a look at our first example. Alright, so our first example is going to be x squared plus 8x plus 7. Remember how I said we're going to look for something that multiplies to make 7, and we're also going to look for something that adds together and makes 8. Or the two things that multiply to make 7 need to add together to make 8. A lot of teachers are going to do it in what they call the Xbox method. So we're going to have two numbers that multiply to make 7, add together to make 8, and that would be 1 and 7. They multiply to make 7, add together to make 8. I'll use this from now on just to keep things more organized, but as you get more practice in, you'll start to mentally keep track of things and do your expansions like that. So we have 1 and we have 7. Those are our key numbers. Since the a value for x squared is 1, we can use just our key numbers to write our factors. We'll write it as x plus 1 and x plus 7. And that's it. That's the factored form of this quadratic. Let's take a look at the next example. Okay, so our next example is x squared minus 11x plus 10. All right, so we need to find two numbers that multiply to make 10, so multiply to make 10, but add together to make negative 11. If we're adding numbers together and we wind up with a negative, at least one of them must be negative. And in this case, we know they both have to be negative because our 10 up here is positive. Because remember, a negative times a negative makes a positive. So we need two negative numbers that multiply to make 10, add together to make 11, and those two numbers are going to be negative 10 and negative 1. Again, we have a nice quadratic here where our a value is equal to 1, so we can use our key numbers directly to make our factors. And plug in x at the beginning, and there we go. There is our factored quadratic. For our next example, we have x squared minus x minus 56. So we need two numbers that multiply to make negative 56, but add together to make negative 1. This negative sign in front of the x means that this is a negative 1. If you don't have a coefficient, you assume that the coefficient is 1. Just like we assume over here, the coefficient is also 1. So, let's see. Factors of 56. They need to be close together because when we're adding them together, we get negative 1. We also know that one of them is going to be positive, one of them is going to be negative, because when they multiply together, we get a negative. So one of them is positive, one of them is negative. Well, 7 and 8 are really close together, and they multiply to make 56. And the 8 should go over here on the negative side, because when we add them together, we're going to get a negative out of it, so the negative has to be larger. The absolute value of the negative has to be larger. So we have our two key numbers, and because our coefficient for the x squared term is 1, we can use the key numbers directly to make our factorization. For our fourth example, we're going to use 5x squared plus 10x plus 20. Now, it does look a little scarier because our a value is not equal to 1, but we can factor out a 5 from each of these terms. Each of these terms is a multiple of 5. So let's do that. We'll factor out 5. 5x divided by, 5x squared divided by 5 is x squared. 10x divided by 5 is 2x. And 20 divided by 5 is 4. Now, let's see if we can factor this any further. Are there two numbers that multiply to make 4, but add together to make 2? There isn't. The factors of 4 are 1, 2, and 4. There's not a combination of these that are going to add together to make 2. So we know that this section here cannot be factored any further. And that means this is the final factored form of this quadratic. Okay, for our final example, we're going to have 5x squared minus 30x plus 40. Just like the last one, 5 is a common factor of each of our three terms, so let's factor out the 5. 5x squared divided by 5 will be x squared. Negative 30x divided by 5 is, oh my gosh, not negative 60. What am I doing? Negative 6x, and 40 divided by 5 is 8. Now, we need to check and make sure that this quadratic cannot be simplified any further, or can't be factored any further. So let's see. Are there two numbers that multiply to make 8, but add together, not to negative 8, but add together to make negative 6? And indeed, there are. We know that they both need to be negative because our 8 up here is positive. Negative times a negative makes a positive. And we know that at least one of them needs to be negative because we're adding them together and getting a negative. So we need two things that add up to make 6, 2 and 4. Negative 2 and negative 4 will multiply together to make 8, and they will add together to make negative 6. So these are our two key numbers, and we can use them directly because our a value for this quadratic is 1. It was 5, and we factored out the 5, so now it's 1. So we have x minus 2, x minus 4, and don't forget we factored out this 5, so we need to include that as one of our factors for the original quadratic. And this is it. That is the factored form of that quadratic. All right. That is it for today. If you found this to be helpful, consider liking and subscribing. And if you have a topic you want me to cover in the future, leave it down in the comments below. As always, have a fantastic day.